Okay, number 28. I love number 28. How come? Because it looks so hard and yet is so simple. All right. So you've got a parabola. It looks roughly like this. Okay, and here's the question. Looks very, very hard. Sounds very, very hard. The equation y equals ax squared plus bx plus c. Oh my gosh. Is graphed in the standard xy coordinate below, plane below, for real values a, b, and c. When y equals 0, which of the following best describes the solutions for x? Oh my gosh. This is smoke and mirrors to fool you. This adds nothing to the problem. You should totally ignore it, okay? But of course it's going to scare the average student to death, right? What is it? What is this? This is the basic formula for a parabola. Well, duh, it's obviously a parabola. It would be if they had said, graph below is y equals mx plus b. Well, yeah, y equals x plus b is a line. I can tell it's a line. In other words, this adds nothing to the problem. This means this is any parabola, but I already knew that, okay? So this meant nothing at all. That was just window dressing to fool you. What matters is this little y equals 0. What they're saying is what's going on in the graph when y equals 0. Now a fourth grader can answer the question, literally. Because fourth grade, the first half of fourth grade is when you learn what an xy coordinate graph is and how to plot points. And that's all you need to do. A fourth grader knows that this is the x-axis, this is the y-axis, and that if y equals 0, you're not going up or down from the origin or from the x-axis. So when y equals 0, all your points are on the x-axis. So the question is saying, what's going on in the graph on the x-axis? Well, what's going on is this and this. Okay, that's what's happening. And the question is, what describes that? Well, let's look at the answer choices. F says there are two different positive real solutions. Well, this is positive, right? But this is negative, so that's not right. G says there's two different negative solutions. No. And then H says there's one positive and one negative solution. Ding, ding, ding. That's the answer. Isn't that incredibly simple? It's a great example of how the ACT tries to fool you by making things look much, much, much harder than they really are.